Hello everyone, welcome to Concepts in Chemistry YouTube channel. So this is the fourth video and there is maximum chance that this video will be the last video of memory based question answer uh, series of Barc 2022 first phase second April exam. So let's discuss some more questions, then we will see. So let's discuss first the questions. So बहुत कोशिश करने के बाद मीन्स ये बहुत याद करने के बाद सो एक्स्ट्रा 10 क्वेश्चंस, फुल क्वेश्चन नहीं है, फुल क्वेश्चन भी नहीं, सो क्वेश्चन का कुछ पार्ट याद आया. सो लेट्स डिस्कस दोस 10 क्वेश्चंस. सो लेट्स स्टार्ट. So this is a very nice questions from chemical equilibrium. So yeah, so our reaction was given like A gaseous species plus B gaseous species equilibrium, C gaseous species plus D gaseous species. So the questions was like that: at equilibrium condition the value of del G and del G 0. So and given in the question the this data was given that K equilibrium is 10 to the power 3 and temperature is 300 Kelvin. So the question was like that: in this above reactions at equilibrium conditions, so del G and del G 0, what are the values of del G and del G 0? So obviously at a particular temperature, the temperature was mentioned as 300 Kelvin. So we know for a reactions like that, A moles of A plus B moles of B react to form C moles of C plus D mole of D. So this is a reversible reactions. For these reactions, if we want to write the Gibbs free energy equations, then del G equal to del G 0 plus RT ln Q. So del G is the Gibbs free energy of the reactions at any moment, and del G 0 is the standard Gibbs free energy. So del G 0 is the standard Gibbs free energy means when the all species are their standard state, and this Q term is called as reaction quotient. So it's the ratio of the concentration of product with appropriate power upon concentration of reactant with appropriate power. So now at equilibrium conditions, this Q term become K equilibrium. So normally at any time Q is called as reaction quotient. This is the concentration value of product upon concentration value of reactant with their appropriate power. At equilibrium conditions means Q at equilibrium we can write as K equilibrium. So K equilibrium is equal to the concentration with appropriate power at equilibrium conditions, concentration of C and D with appropriate power at equilibrium condition upon concentration of A and B at equilibrium condition with their appropriate power. So we also know at equilibrium conditions del G equal to 0. So we already know that at equilibrium condition del G means the Gibbs free energy of the reactions should be 0. So if we put 0 in this equation here, 0, considering the equilibrium condition, then del G 0 plus RT ln in place of Q we will write K equilibrium, because we know that at equilibrium conditions the reaction quotient Q become K equilibrium, that is equilibrium constant, and this del G becomes 0, not del G 0. Del G becomes 0 at equilibrium constant at equilibrium conditions. So from at equilibrium condition we can write from these equations del G 0. So del G 0 become minus RT ln K equilibrium. So so at equilibrium conditions del G equal to 0 and del G 0 equal to minus RT ln Ku. So from this if we put this value del z 0 is equal to minus RT ln k equilibrium, then we will get del z equal to minus RT ln k equilibrium, means we put the value of del z 0 here, minus RT ln k equilibrium plus RT ln q. So you can write any reactions, the change in Gibbs free energy. Now del z 0 is equal to minus RT ln k equilibrium. So minus RT ln k equilibrium was given as 10 to the power 3. So if we put the value here, ln was given, so we convert into a log log 10 base term, so multiplying 2.303. Now if we put the value, then it's become 17 minus 17232, means 17,232 joules. So it's become minus 17.2 kilojoule. So the del z 0 become minus 17.2 kilojoule, but del z is equal to 0 since it is an equilibrium conditions. So the options were like del z equal to 0 and del z 0 equal to minus 17.2 kilojoule. Yeah, exact. Remember the values, all the values in this for these questions. So the del z means the Gibbs free energy of our reactions at any moments. Del z is equal to 0 at equilibrium conditions, and we know that del z 0 standard Gibbs free energy is equal to minus RT ln k equilibrium. So this is reaction quotient. Reaction quotient become k equilibrium at equilibrium condition. So this is question number 41. We already discussed 40 questions. This is question number 41. So let's move to the next question. So this is another questions from mathematics. So I think I already discussed one questions from mathematics. So as much as I can remember that there were 5 questions from mathematics, 3 or 4 from differential equations and 1 from that limit. So all the mathematical questions from differential equations, and those are easy questions. So this is the differential equation. So differential equation like this, d2y dx2 plus a square y. So here this constant term equal to 0. So the general solution of this above equations, we can write y equal to a sin ax plus b cos ax if this is a square. So here a square means this 25 means 5 whole square. So a sin 5x plus b cos 5x. This is the general solution of this differential equation, second order. So this is the general form, d2y dx2 plus m square y. If this is the differential equation second order, then the general solution of this second order differential equation will be y equal to a sin mx plus b cos mx. This square term m square will be in that sin term, a sin mx plus b cos mx. Now just for extra information, I put this differential equation also. So question in the question paper, the question was like this, this plus d2y dx2 plus 25y, but if there is minus term d2y dx2 minus m square y, or there will be anything in place of m square, it's 25, it's 16, it's obviously a square term means 16 means 4 square, 25 means 5 square, 36 means 6 square. So this is a constant term. So in that case, the general solution of this differential equation will be y equal to a e to the power mx plus b e to the power minus mx. Just changing the sign here, the general solution of these equations become changed. In this case, y equal to a e to the power mx plus b e to the power minus mx. A, b are constant. So a, b are constant. In this case, a and a or b are constants. So this is the mathematical. Yeah, you can see some, you can look for some mathematical questions, simply mathematical questions, since they asked 4 to 5 questions from differential equations. So you can look for some simple mathematical portions from differential equations. So I think in next phase exam means 6th April, they will also ask the questions from mathematics, mathematical questions. So if you have time, then just look for some mathematical questions like this and some formulas regarding these differential equations. So let's move to the next question. Yeah, other questions from organic chemistry. So ये क्वेश्चंस याद नहीं आ रहा था, सो बहुत कोशिश करने के बाद ये वाला क्वेश्चंस याद आया जो फोटोकेमिस्ट्री रिलेटेड था मींस नॉलेज टाइप 1 क्वेश्चंस. So this is a knowledge type 1 questions, NS1. Normally we used to say that this type of reactions. So the question was like that, light and ethanol, what will be the product? So I forgot the options, but yeah, let's discuss this type of reactions, some details, so that in upcoming Barc exam or upcoming NET, GATE or any exam, so it will help you a lot. So this is knowledge type 1 reactions, NS1, from photochemistry. So if carbonyl compound like this, cyclopentanone, cyclic ketone, if we treated this molecule with light, if in gas phase reaction, if the reaction will occur in a gas phase, means there is no solutions, gas phase reactions, then first this bond cleavage, homolytic cleavage, to form a radical, alkyl radical, and this carbonyl radical. In gas phase in gas phase conditions means no solutions. In reaction medium there is no solutions. CO group left to form a dialkyl radical. Now this dialkyl radical either cyclized or this radical abstract on hydrogen from this, and then these two radical combine to form a double bond, and here that hydrogen will attach. In gas phase, first condition. Second possibility is that this carbonyl radical abstract on hydrogen from these positions to convert is a aldehyde, and then this two radical just form a bond to form a double bond. So this is alpha, beta, gamma, delta, gamma delta unsaturated carbonyl compound. So this is the case of gas phase reaction. If we treated cyclopentanone molecule with light without any solvent, if we use any solvent for these reactions, then first the radical form, then there is chance like this there is chance this radical abstract one hydrogen from these positions, and then this adjacent radical form a bond to form a double bond, means gamma delta unsaturated carbonyl compound, like in this way. But there is a possibility of to form a ketene. So this radical abstract on hydrogen from this carbon to form a radical in these positions, and after that this radical combine with this radical to form a ketene. If we used a polar protic solvents, so polar protic solvent means water or alcohol, so then this polar protic solvent will attack this ketene to form a ester molecule. So this is the general mechanism for NS on knowledge type 1 reactions in gas phase, in solution phase. Normally in solution phase, decarbonylation means leaving of CO group is not normally not take place in solution phase. But if there is in solution phase, if there is chance to form a very stable radical after decarbonylation, means after leaving the CO group, if there is chance to form a stable alkyl radical, then in solution phase also CO group leaves. But usually in solution phase normally CO group cannot leave. Chance are two in solution phase, either it's formed like this gamma delta unsaturated aldehyde or ketene to form at last A star in presence of polar protic solvent. But if there is a chance to form a stable diradical, then in solution phase also decarbonylation means so decarbonylation means CO group leaves CO group, from this CO group leaves as CO carbon monoxide to form diradical. See, in this diradical, these are 3-degree diradical, so stable diradical. In this, that's why in this case CO group can be left as carbon monoxide. Otherwise, normally in solution phase, decarbonylation means leaving of CO group is not possible. In gas phase, decarbonation normally occurs, but in solution phase, decarbonation normally don't take place. If there is a chance to form a stable radical after decarbonylation, then there is a chance for decarbonylation to take place. So if this carbonyl group leaves as a CO carbon monoxide, then diradical form. Then the diradical either combine to form a cyclic molecule, or this radical abstract one hydrogen from this side, or this radical abstract one hydrogen from this side to form a like terminal, and this to form a alkene like this. So in the given questions, alcohol was there. So I forgot the product exact structure of the option of the product. So there will be maximum chance like this product like this, at least in on options the product like this should be there. So since we use ethanol means polar protic solvents, and see, so in that case if CO group leaves solution phase, if CO group leaves, then one side radical is stable, but if CO group leaves as a carbon monoxide, then the radical form is a primary radical. So that's why in this case CO group cannot leave as carbon monoxide, so it's turned into a ketene, and then the ketene react with ethanol to form a ester like this. So for some extra information, I put another example because this example already asked in the question. So this type of questions may be asked in upcoming exam. So this is also a cyclic ketone. So if you use light in place of methanol, then first this bond will break, because if this bond break, then stable radical 3-degree radical will form. If this bond radical first, then here primary radical will form. So first this bond break to form a stable radical and one radical as carbonyl carbon. Then this this 3-degree radical abstract this hydrogen to form a ketene, and after that this methanol attack this ketene to form a ester like this. So for just extra information, to practice on extra questions, I just put this example. So I think it will help you for upcoming exam purpose. So let's move to the next question. So on questions from phosphorescence, just 4 statements was there. 4 statements are there that phosphorescence happens due to change of excited state from singlet to triplet, or change of excited state from triplet to singlet. So statement like 4 options are there, but the questions, as much as I can remember, 90% the questions was like that: the phosphorescence happens due to change of excited state. So from Jablonski diagram we know that if electron excites, then from ground state, singlet ground state, is moved to the first excited state. Then from this is first electronic excited state, S1 means S0 means electronic singlet excited state, T means triplet electronic excited state, and these are vibrational state. So within one electronic state there are so many vibrational state. So first excitement occur, then there is deactivation occur within this singlet electronic state. Among the vibrational states deactivation occurs. So this is called, from this vibrational state to this vibrational state, if that deactivation occurs, this is called vibrational cascade. Now we all know that from singlet state to triplet state, when it is this spin change will occur, and via intersystem crossing, means intersystem crossing from singlet state to triplet state, when it goes to triplet states, then from triplet state to again singlet ground state, when it is returned back, then we will observe the phosphorescence phenomena. So the excited state, so this is ground state, it goes to excited state. Now the excited state changes to singlet to triplet, and from triplet state, when it's returned back to ground state, then we will observe the phosphorescence phenomena. Or fluorescence, when this excitation occur from ground state to any of the electronic state, singlet, this is singlet 1, singlet 2 will be there, any of the excited state, that is obviously of same spin multiplicity, and from singlet S1 or singlet S2, if it will return back to S0, means singlet state to singlet state, then we will get fluorescence phenomenon. So phosphorescence, excitation, singlet to singlet, then excited state transform singlet to triplet, then deactivation triplet to singlet, we will get phosphorescence. Fluorescence, singlet to singlet excited state, no change, singlet to again singlet, deactivations mean returning, excitations, deactivations, we will get fluorescence. So phosphorescence related ये questions उन लोगों ने पूछा था. So I already told you that partially कुछ क्वेश्चन मुझे याद आ गया, इसलिए मैंने ये लास्ट वीडियो, मैक्सिमम पॉसिबल चांस है ये लास्ट वीडियो होगा, बिकॉज बहुत याद करने के बाद बाकी जो क्वेश्चन मिला मैंने ये अभी डिस्कस ये वाला वीडियो में वो क्वेश्चन हम लोग अभी डिस्कस करेंगे. बाकी आगे और अगर कुछ क्वेश्चंस याद आएगा तो ऑब्वियसली I will share with you. So let's move to the next questions. So peak ratio in mass spectrum. So chloroform was given. So Cl3 was given. So peak ratio of the mass spectrum. So Cl35 is to Cl37, 3:1. This data was given. So what will be the peak ratio? So we already know that for halogen, if one halogen means chlorine was there, then the isotopic peak will be 1, means M and M plus 2. If 2 halogen is there, chlorine, then M plus 2, M plus 4 will be there. 2 extra isotopic peak along with the molecular peak. If 3 chlorine was there, then we will get 3 isotopic peak along with the molecular peak, means M molecular peak, M plus 2, M plus 4, M plus 6, we will get total 3 isotopic peak plus molecular peak. So see, the Cl35 is to Cl37 ratio 3:1. We already know from mass spectrometry that how to we calculate the ratio. So M means in 3 chlorine in 35. So chlorine in 35. So the mass of chlorine is 35. For M only, M plus 2. So among 3 chlorine, 1 chlorine should be 37. So since there is 3 chlorine, so one combination is 2 chlorine 35, 1 chlorine 37. So it's become M plus 2. One combination is there. So first chlorine is 35, second chlorine 37, again third chlorine 35. So in this way we can calculate the ratio. So it's become 27 is to 27 is to 9 is to 1. So this 3 3 3 3 into 3 into 3 20, so 27. For these combinations, for 35Cl 3 into 3, for 37 into 1, plus this combination also 3 into 3 into 1, for this combination also 3 into 3 into 1, so 27. For M plus 4, to obtain M plus 4 peak, among these 3 chlorine, 1 chlorine should be in 35, another 2 chlorine should be in 37, means chlorine 37. So there will also 3 combination, means first chlorine and second chlorine 37, third chlorine 35. Second combination, first chlorine and third chlorine will be 37 and second chlorine 35. Third combination, first chlorine 35, second and third chlorine 37. So we will get M plus 4 peak, and if we calculate the ratio, so for 37 1 into 1, for 35 3. So 1 into 1 into 3 means 3 plus 3 plus 3 into 9. And for 37, if we want M plus 6, means we have to consider the 37 chlorine for 3 cases. As we consider to obtain molecular peak, we consider 35 chlorine 35 for 3 chlorine. So the same as if we want to M plus 6, we have to consider chlorine 37s for 3 chlorines. So 27 is to 27 is to 9 is to 1. So this is the peak ratio of M plus 2, M plus 4, M plus 6, since there are 3 chlorine atom. If there is 2 chlorine atom, then you have to find M plus 2 and M plus 4 peak. So let's move to the next questions. So one amino acid is there. This is aspartic acid amino acid. So yeah, this is the exact questions I put. So the pK value of this hydrogen, this carboxylic acid 2.2, this carboxylic acid is 4.2, and this NH2 is 9.7 pK value. So at pH 3, what form will exist? So see, these are the pK value of this hydrogen 4.2, this hydrogen 2.2, this hydrogen 9.7. So at pH 3, so at pH 3, so at pH 3 only this carboxylic acids will deprotonate, because pK value of this hydrogen is 2.2, greater than this pH. That's why these carboxylic acids will turn, this carboxylate acid will deprotonate, means it will turn into a carboxylate anion, and this pK value of this carboxylic acid, means this hydrogen is 4.2, but the pH is 3, means less than this the pK value of this. That's why there will be no deprotonation of this CO2H group. So at pH 3, since it is 9.7 the pK value and this pH 3 is very low, so this NH2 also will be in protonated form. So at pH 3, this COOH will be in deprotonated form, this NH2 will be in protonated form, means NH3 plus COO minus, and this CO2H group will be as such as. So this is the questions from amino acids. So let's move to the next questions. So this is kind of not operator, but somewhat scalar and vector properties. So this is obviously an operator. So this is a vector quantity as given. So I del dx, d dyx, d dz. These are the directions, means since it is a vector quantity, so I, j and k, the x direction and z direction of the unit vector towards each directions, means x, y and z directions. So we have to find the value of this quantity. We have to find the value of this quantity. Phi is a scalar function. So if we multiply any quantity that is scalar, if we multiply a scalar quantity with a vector, then just the scalar quantity just the scalar quantity. If we multiply any scalar quantity with a vector, just this scalar quantity, there is no change in the what I can say, that vector term. Means if see here, so this is given as a vector. If we write this as a scalar quantity, then we can write del x plus del y plus del z. There should be no I cap, j cap, k cap, because this is a scalar quantity. There is no directions, so only the value we have to consider. So this quantity will just we have to multiply in that vector quantity. So to find this value, so since this value is I del x, j cap del y, k cap del z, so we have to just multiply this term with this term, just normal multiplication. So we will get I del square dy square del square dz square into 5. So now we can write this term in the bracket, that is del square. Means since I, j, k is there in this term, so normally it is delta. This is the sign of directions. Now after multiplications, it's become the square term. Now we can write, obviously there will be a this sign, means I, j, k term will be there. That's why this we will write delta directions square into this phi term, means scalar. So we cannot write this term as a normal delta, means there is no directions, and if we write without any direction sign, just square, then it will be the wrong answer. Scalar functions we multiply with the vector quantity. Now we will get this term as a square terms, and obviously I, j, k will be there. That's why this whole term become delta with directions square into phi. So this is some scalar and vector properties. Let's move to the next questions. So graphite related on question tha. So the questions I partially remembered that graphite layers are arranged in which way. So both चार ऑप्शन था, उस ऑप्शन से शायद एक दो ऑप्शन में, मींस एक दो ऑप्शन में ए एंड बी और ओनली ए, ऐसा कुछ ऑप्शन था. सो ग्राफाइट लेयर अरेंज्ड in graphite layer, we will see two types of arrangements. AB means Bernal stacking, that is for alpha graphite, and ABC, that is rhombohedral stacking, that is beta graphite. So in graphite layer we will see two types of arrangements, like AB called as Bernal stacking, it's for alpha graphite, and ABC rhombohedral stacking, it's for beta graphite. So we will normally used to see two types of arrangement in graphite layers. So next question is, yeah, this type of question was given for any gaseous species, work equal to minus p external dv. Now for applicable for van der Waals equations, which I think there are four equations, like four equations of work or four expression of works, like that. So we have to find which relation is perfectly hold for van der Waals equations, means van der Waals gases. So we know the van der Waals gases, so this we can write. So this term become as a p external term for van der Waals gases. So if p external is a pressure of ideal gas, then RT by V minus B minus A by V square. This whole term we can write as a P external. So from van der Waals equations, if we rearrange to write the P term, then it will become RT by V minus B minus A by V square, obviously for 1 mole of gases. So this equations is perfectly hold. This whole equations for work, the expression for work done is applicable for van der Waals equation or van der Waals gases. So question number 51, and this is going to be the last questions of this question answer discussion series. So ionization potential of hydrogen was given as minus 13.6 electron volt. Now we have to find the ionization potential of helium plus. So options were like that: minus 13.6 into 2 electron volt into 4 into 8 into root 2 और कुछ था एक ऑप्शन में. So वो मुझे पूरा याद नहीं है, but so we know that the ionization potential of species like, so species means minus 13.6 Z square by N square. Z is the so atomic number, so that is the atomic number, and N is the which electron, that electron is which electron, the electron we are considering, it is in which. So so N is the number of so quantum number, in which quantum number the quantum state the electron is moving or electron is rest. So not rest, electron is always moving. So IP, ionization potential of any species, minus 13.6 Z square by N square. Z is the atomic number of that species, and N square is the N is the quantum number, which quantum state means which electronic state. So it is the electron is moving. So for helium plus, Z is 2, since it's plus. So only one electron is there. Helium plus means only one electron is there, and that electron is surrounding. So N equal to 1 shell. So N is equal to 1 for this helium plus. N is equal to 1 electronic state. The electron is moving. So if we put the value N is equal to 1 and Z is equal to 2, then we will get minus 13.6 into 4. So minus 13.6 into 4 electron volt is the ionization potential for helium plus. So हम लोगों ने हाफ क्वेश्चन डिस्कस कर लिया. सो ये जो एग्जाम बार्क जो एग्जाम नॉर्मली होता है, सो उसमें टाइम बहुत कम मिलता है. सो इट इज इम्पॉसिबल फॉर मैक्सिमम कैंडिडेट टू सी ऑल द क्वेश्चंस विद इन 2 hours. सो जितना मुझे याद आया डिस्कस हम लोगों ने कर लिया. सो इस डिस्कशन में बहुत आई थिंक see we already discussed 51 questions. So in these questions, in these discussions, so ये हो सकता है मैक्सिमम, बट मैक्सिमम केस में नहीं होगा. हो सकता है कोई भी आंसर मैंने कुछ गलत बोल दिया हो, बट हो सकता है मेरा हर आंसर सही नहीं होगा. I am honestly telling you that and frankly telling you that all the answers I discussed, I already shared with you. Yeah, I am telling you that 95% केस में जो आंसर मैंने डिस्कस किया, हम लोगों ने डिस्कस करा, वो आंसर सही होगा. बट देयर इज सम केसेस जो मैंने आंसर बोल दिया, अभी डिस्कस भी कर लिया, ये आंसर ये क्वेश्चन का होगा, ये हो सकता है, वो शायद नहीं होगा. सो सो देयर विल बी मैक्सिमम चांस. हम लोगों ने तो डिस्कस किया, वो आंसर सही रहेगा. बट ठीक है. और नेक्स्ट फेज एग्जाम मीन्स बार्क सेकेंड फेज एग्जाम 6 अप्रैल. सो 2 दिन बाकी है. सो आई थिंक ये क्वेश्चन डिस्कशन सीरीज आप लोगों को बहुत हेल्प करेगा नेक्स्ट बार्क एग्जाम के लिए और अपकमिंग नेट गेट एग्जाम के लिए भी। बस आई वांट टू टेल यू वन थिंग दैट एग्जाम, आई होप एंड आई बिलीव दैट एग्जाम इजी रहेगा। सो एग्जाम विल बी इजी बट टू मेंटेनिंग टाइम, बिकॉज उन लोगों को पता है ये टाइम मेंटेन नहीं होगा, इसलिए क्वेश्चन शायद इजी होगा। सो टाइम मेंटेन करना बहुत ज़रूरी है। सो ट्राई करना एज मच एज मैक्सिमम क्वेश्चन अटेंड करने का आप लोग ट्राई करिएगा। बाकी सो लेट्स सी। सो नेक्स्ट फेज का जो क्वेश्चन आंसर डिस्कशन वो शायद ऐसा नहीं होगा एज सुन एज पॉसिबल, बिकॉज नेक्स्ट फेज एग्जाम सो मैं नहीं दे रहा हूँ नेक्स्ट फेज एग्जाम, बिकॉज आई ऑलरेडी ये वाला एग्जाम जो सेकेंड एपिसोड में होगा ये एग्जाम मैंने दिया। सो जो क्वेश्चन मुझे याद आया डिस्कस कर लिया। सो लेट्स सी व्हाट हैपन इन द नेक्स्ट फेज एग्जाम, वी विल डिस्कस टुगेदर। एंड सो टेंशन एंड प्रेशर नहीं लेना है बस। ओके, one point I want to mention that the radioactivity. So in the radioactivity video, in the video I already discussed 9 to 8 questions from radioactivity. Similar type of questions उन लोगों ने पूछा था क्वेश्चन में, बट मेरे को एक भी क्वेश्चन याद नहीं है रेडियो एक्टिविटी का। एलिमेंट भी याद नहीं है कौन सा एलिमेंट था। जस्ट उन लोगों ने ए एलिमेंट अल्फा बीटा एमिट किया, प्रोडक्ट क्या होगा, प्रोडक्ट में एक्स वाई था, जस्ट ऐसा ही क्वेश्चन था रेडियो एक्टिविटी का। सो रेडियो एक्टिविटी का क्वेश्चन शायद मुझे लगा है, मुझे लगता है रेडियो एक्टिविटी क्वेश्चन का पूरा क्वेश्चन आप लोग कर पाओगे रेडियो एक्टिविटी का। उतना टॉप क्वेश्चन रेडियो एक्टिविटी नहीं नॉर्मली आता है, आई बिलीव। सो नहीं आएगा इस टाइम पे भी। सो ऑर्गेनिक क्वेश्चन से बहुत सारा क्वेश्चन पूछे थे, फिजिकल केमिस्ट्री से बहुत सारा, इनऑर्गेनिक से बहुत कम क्वेश्चन इस बार ने पूछे थे। सो आई थिंक ये वाला सीरीज मेमोरी बेस्ड क्वेश्चन आंसर सीरीज आप लोगों को बहुत हेल्प करेगा। सो थैंक यू फॉर वॉचिंग एंड थैंक यू फॉर योर सपोर्ट। सो वी विल डिस्कस lots of conceptual questions in our upcoming videos that will help you a lot for upcoming NET GATE exam. So stay tuned. Thank you for watching again, you guys. So thank you and stay safe, stay healthy. So all the best for next Barc exam. Best of luck, guys.